So, as should we begin?
Yep.
All right. So I guess Zhang's having some issues with his microphone, so I'll be leading this. I'm just gonna run through the agenda here. Where are we? Got a lot of tabs. Okay. So first on the agenda, I guess, Gero, you've got your testing cluster information.
Can you guys hear me?
You need my.
Can you hear me? Share my screen. Oh, I can see my screen. Okay. That's good. Okay, today I'm going to talk about two things. First, we built like internet demo for like SCD. It's called play.scd.io. So you can go to this website now. So it is like SCD. We set up the SCD public cluster. So you can just like go to here and then just like play with SCD and then see how SCD works in the backend, and then code is here. So this is how it looks like. So let me show you how it works. Okay. So if you go to play.scd.io, you can see these like 5 nodes. And then like blue means the node is follower, and then green means the node is leader. And then you can just click like one node to see more information. And then you can even kill like each node, like whichever like node you want. So I will show you just like one failure case. We're gonna kill the like leader. Okay, here. So if you click the button kill, it's gonna kill the leader. And then in the Raft algorithm, if you don't get the heartbeat from like valid leader in the election timeout, they're gonna like elect a new leader. So you can see like node 3 is down, but like node 5 is got elected as a new leader. And then you can just like recover like this node by clicking the button restart. And then you can do like simple client request. Yes. And then click the button submit. So this is like very simple. Like we just like made it simple just so that people can like see how it works. And then another thing. So like since February, we've been like testing SCD like version 3. So like in addition to like integration tests and the unit tests, just like code tests, we have the functional test. So like this is still like experimental, like we're still trying to stabilize, but the dashboard is like public now. So we like published the testing result into like dash.scd.io. So you can go here later to check the result. But it's still like, it's not like stable. We're still trying to like make it more stable. So it's like simple dashboard, like built like based on the Prometheus and then Grafana. So this is how it looks like. So we show like how many rounds we have it like running, and then how many rounds like it has like failed. So this is how we do this. So we want to test SCD cluster like same as people run SCD in the production environment. And then this is testing SCD in the under like high pressure. And then like we inject like a lot of failures. Like it's like more than enough. Like, and then like from this test, like we want to find like bugs like before we push, like before we release like SCD to like public. So this is only for version 3. Like we're gonna do some like benchmark, like version 2 versus like version 3 later. But for now, this is only for version 3. And then like we inject failures like every like 3 or 5 seconds. So if you look at the number, it's like a lot of failures, like almost like 30K failures per day. And then like we just like run this like testing cluster like 24/7. And then we also want to make sure not just like panics or errors from SCD. We want to make sure SCD keep the data consistent. So after every round, we compare the like hash values of the like database. Just make sure like SCD distribute the data like in the like consistent way. And then we also monitor the SCD performance, and then like metrics like CPU usage and the memory usage. So this is like failure cases like we've been testing. So like there's like a lot of like more cases we can try, but for now we kill like every member and then recover, and then check the hash value, and then check like data. And then we like right now we like running like 3 member cluster. So we kill like 2 members and then see if like SCD still functions, like can like process like client request, and then like kill like 1 member and then recover, and then kill leader. And then like isolate, like we try to like simulate like bad network, like dropping the port in the cluster. So we've been running like only 1 month, and then we already found like 2 critical issues, and then failure rate is like pretty low like already. So like one of the issue like we found there's a panics in our upstream like package VoltDB. So Xiang like filed an issue to upstream VoltDB, and then he helped the VoltDB like figure out like what was wrong, and then it's like fixed. It hasn't been merged to master branch, but it will be like merged like next week. So like, and then other thing like we were stressing the cluster like too fast. So like we found some issues like running out of memory, but also like Xiang and Anthony like found a way to like fix this, like rate limiting the like client request in the like server side. So yeah, this is like it will be fixed like this week or next week. And then like several other issues in the like cluster, like functional tester code. So this is like still experimental. So we're gonna do a lot more testing, and then we want to have like almost like 0 like failure rate. And then right now we run this testing cluster only like 3 node, but we want to test with like 5 node. And then not just 1 cluster, we want to like run like several like tens of like clusters at the same time. And then like more failure scenarios. So right now it's like very simple. We just like dropping the port to simulate like bad network, but I want to simulate like slow network, like something like network partition. And then we're gonna do more like benchmark and then performance analysis. yeah, like I think like, this is all I have.
Great.
Yeah.
Thank you. All right. See where we are. Back to the agenda. Does anyone have any comments on that? Questions out there in TV land? Am I going to be talking about mirrormaker then? Okay. So I guess I am going to be talking about the Etsy D3 client design. So I didn't know I was going to be talking about this. I don't have much prepared, but I can launch into a terminal window and go over it a little bit. Let's see. How do you do screen sharing? Oh, all right. Oh, you're sharing.
On.
Yeah. All right. Let's see here. Here. Let me. Okay. Am I showing up well?
Yes.
The font size okay?
Yeah.
All right. So been working on the client library for Etsy D3. It's in a good state now, so I'll go over it a little bit. So the main thing is you create an instance of a client, and that client will expose a few interfaces for the API, the cluster interface, key value interface, list interface, and watcher interface. The client automatically manages connections to the endpoints. So if an endpoint is drops out, it'll connect to the next one. So the just in terms of the interfaces, they're very straightforward implementations of essentially the RPC calls. We have some extra support for extensibility in that we can provide options to most of the requests. So that way you can say with some option and then continue on, and that way you don't need special functions or anything like that. So KV interface is put, get, delete, compact, as well as transactions. Transactions are probably worth mentioning because they also have a variadic interface, which lets you define a variable number of comparisons, a variable number of operations for then, and a variable number of operations for else. There is the cluster interface, which is very similar to the Etsy D2 cluster interface. I'm not going to go much into that. We have, there's the lease interface. So the lease interface uses channels for keep alive. So long as the lease is active, it'll send keep alive over a keep alive response channel. And when the lease goes away, that channel closes. So that's how you know the lease has vanished. Similarly, in terms of channels, the watcher interface also heavily uses channels. So there's one call for the watcher interface, which is watch, and this will give you a channel which will be updated based on watch events. And the interface is very similar to the get interface. So watch is like a long-term get, essentially. So that's the V3 client in a nutshell. It's very Go specific right now, mainly because of the channel stuff. If anyone wants to help out with bindings in other languages, that would be super great. I guess you can communicate with us on GitHub for that. Let's see. I also have an introduction to this Raft example thing that I wrote a while back. Find the slides. get into the slides here.
Yeah, I can see.
All right, I'm just gonna, all right,
Yeah.
That's good. Okay, so a few slides on this Raft example thing. So a problem we were facing was that we want people to use a Raft library, but it's not exactly clear how to use the Raft library if you're just looking at etcd, because etcd is sort of a large project. Additionally, if you're just looking at the etcd code, it sort of hides the basic principles of Raft, and that it's a distributed journal. And we want people to use Raft for things besides than just like a key value store. So we developed this Raft example code that uses basically only Raft, Raft HTTP, and our write-ahead log code. And the idea is to create a minimalistic distributed key value store. It's not going to win any races, but it gets the job done. And the key idea is it needs to be simple to understand, simple to extend so people can hack on it. And the code, I think it's like 350 lines. It's very short. The interface is simple. So the idea is that you can communicate with this Raft layer using channels. You can propose values that are basically strings. So for the KV case, we just gob encode it. And then those strings are then, when it goes to the Raft consensus, it's committed over a channel, and that can be written back to a store. Additionally, thanks to some community support, it also supports configuration changes, so you can dynamically add and remove nodes. And there's also an error channel, so you know what went wrong. And that's the only interface, just those 4 channels. It's very, very simple. And just to show that it can be used for things besides key value stores, I wrote a little example using SQL, and the idea is that you have a distributed SQL instance that works by sending SQL queries over the Raft consensus protocol, and then when it commits, it's committed back to an SQLite database, which is very cool. And I have a demo. I'll show that. I'm not hosting on my laptop because I suspect things will go wrong. All right, so I am going to start, clear the database, then start an instance. So starting in Gorman, and there it goes. Open up another terminal. All right, and so I'm going to populate this with some data. So I wrote a little script that reads off a table of people's preferred snacks, and so I'll load that into the table. It goes kind of slow because I'm hosting off a hard drive instead of SSD, and you can then do a query, if it will let me, and if it will let me. Copy, paste. Okay, so it can do a query. That's a select all, and it can do it from any node. Meanwhile, I can get rid of nodes. So I'm just going to knock off node 1. All right, and we see that node 1 is dead. If I try it, right, nothing. Then I can try it again, and it shows up. And that is the distributed SQL using Raft example. Switch screens again. Right. And availability, so the Raft example stuff's on GitHub under contrib/Raft example, and Raft SQL is under chd/Raft SQL. You can just search for it, it's not hard to find. All right, so that's that. On with the agenda.
So Raft example is we only store data in memory.
Oh yeah. Okay. So yeah, it uses the write-ahead log, so that is written to disk. It doesn't support snapshots though, so the log will just get bigger and bigger and bigger, depending on what backend you use. So like if you're doing like the minimalistic KV store, that's all memory, so it just uses a Go map. But for the SQL thing, it goes through SQLite, and that hits disk as far as I know. Any questions in TV land? No? All right. Let's see what else we got. Okay, so moving on. Since Zhang's microphone isn't working, I'll be talking about our snapshotter and mirrormaker. These slides are new to me, so if I don't butcher them too bad. Okay. Are we showing up? Right. I'm just gonna wing this. These are Zhang's slides. This is mirrormaker. I wrote the original version. Zhang cleaned it up. Good effort. So the idea here is that you have separate etcd clusters, and you want to be able to mirror data from one cluster to another. And this is where this mirrormaker thing comes in. So this works directly through etcd cuddle. You just say etcd cuddle mirrormaker, and you point at one etcd instance, and you point at another. You give it a prefix, and it will mirror the data from one to the other. Oh, he has an animation too. So you have this key foo equals bar. You have a mirror maker, which is tracking all updates on etcd DC0 here, and it will then take the data that it sees, and then it will replicate that to any destination nodes. In this case, we have these mirror nodes DC1 and DC2, and it's sending out the key value over to the destinations. And now, as you can see, all nodes have that information. The implementation is very simple. We just use our watchers and get API commands. We don't have anything special. This is kind of motivation to make our API really reliable. So the idea here is first we get the initial base state. So we read off all the data for a prefix. Oh, we're ending soon. Okay. So we read off all the data from a given revision, and then we start watching on that prefix until there is, I guess forever. So this is the initial base state. Very simple. We just keep on getting all the data. We paginate on every 1,000 keys. After that, we just simply watch for updates. It's very simple code, and that's it. Any questions?
So do you store like historical data, like so history of key, like revisions?
The revisions get clobbered.
Okay.
So yeah, that's the one downside of revision data. The metadata gets all stripped.
Okay.
So we'll have the sequence.
Okay.
But we won't have the right revision. So if we're trying to do things like locks or something on top of that, or like understand that won't work. Okay. But it'll give you just the data.
Okay. So like the last value.
Well, you won't. No. Well, you do get historical data. So long as you're watching that stream, if there's an update to the same key multiple times, then you can still have the historical data. It's just that the revisions don't correspond to the original cluster. Yeah. And we think that's fine. Because it's a read-only mirror. All right. What else we got? etcd3 and Kubernetes plans. I don't know what this is. Zhang knows this. Do you know anything about it? I know that they made some really good progress. Like they were able to bootstrap Kubernetes with etcd3, I guess last week or I guess Monday.
Yeah, just like Friday.
Just yeah, and so that's working out great. That's it, I guess. So any questions or comments? TV Land? Maybe John has something in chat. No, he's got nothing. Okay. So that concludes the community meeting for etcd March 1st. Thanks, everyone.
Thank you.